eco-design is, if you look at it as a principle here, it includes thinking how to make the product economical so people can buy, and it should factor ecological considerations, right? What we talked about of greening. And then, of course, it must deliver what it is expected to. So design must be sound. You can't compromise on the use-related expectations about that product. All that when we put together, it should lead to something innovative, which we call as an eco-design. Now, our basis of thinking in greening is always life cycle. So, whenever you work on a greening project, you should have the imagination, information, and outreach to draw this diagram of a life cycle of the product that you want to work with. Right? So, it's important that you develop such a life cycle diagram. So, design is one of the upstream elements, but then you will follow that design to manufacture. And you can't probably do everything, so you may have component suppliers. And once you are done with the product, you will have to transport it. And then that product will get into the use phase. And then after the use, it will reach end of life, so EOL. And then it will probably otherwise go to the landfill or get incinerated. But then to avoid everything going to the landfill, you would look at possibilities of reuse, repair, remanufacture, recycle. You can add all kinds of R's here, so that you have the reverse flow happening of the components and the materials at different points of the life cycle. It doesn't have to go all the way to the manufacturing phase. Some may find entry points somewhere else. Right? So this is a typical life cycle of a product, and what we want to do is be predictive, be speculative, and if you design something, what will happen to the material and the energy flow in different stages of this life cycle. So people have used a lot of software tools, just like you heard for the building design. You have software tools for simulating, let's say, illumination as one case, or the heat dissipation. And you also have software for taking you to understand the impact of the design what you do in the whole life cycle. Any software you have heard like this for products? There are many, but the one which often are talked about, one of them I will just mention is SIMA Pro, SIMA Pro, and you can get, I'm sure there are demo versions available, and you can just get a feel at how these software work on the design. And there are also such software developed in Japan in their own different way. The SIMA Pro is typically a European-based software. Now, these principles of eco-design, if you look at them, there are 7 to my mind. And the first is we want to reduce the mass of the product. You know, it's simple thinking, that you want to reduce the weight. So what does it mean? That the material intensity will reduce. Your transportation costs also could reduce because you're carrying the lightweight product. So embodied energy, because the mass is reduced, is also reduced. Transportation costs are reduced, and also the disposal costs are also possibly reduced. So mass is very important. So the first mandate, when we all sit like product designers, we give them a challenge. How about reducing the mass, and think how to reduce the mass. See, I do sometimes a lot of workshops in the industry on this topic. So what we do is we tell people half an hour, this is the product which you already make, figure out how can we make 20% less weight. And everybody applies their mind to figure out how could that be done. So you would use different material first, right? A more lightweight material. If you use lightweight material, then you are worried about its strength. So then you want to look at some composite, some alloy, some new form of material which is lightweight but yet meets your requirement of, let's say, compressive strength. Yeah? So that's one way that we look at it, to make the mass as light as possible. Second, of course, that input energy going in making that product, you want to reduce, right? But not just making the product, remember, we are talking about life cycle. So the energy consumption, even in the use phase, we want to think about. And then say that net energy input, making and using and in getting rid of it at the end of life, we want to see minimum possible use of energy. Then you don't want to see harmful substances. So you will figure out all the components gone in and then look at their hazard rating, and then you will say that some of these materials should be substituted by non-hazardous substances. Having then done that, because we are looking at life cycle, we want to ensure that the product in its various components is recyclable. In some cases, products simply are not recyclable because the way we are choosing, let's say, the materials, they make it very hard to get them in the recyclable form. So we have to assess the recyclability of that product, or to improve on it as much we can. And as I said, product is also got packaging. So as we discuss the mass of the product, we also want to make the packaging as light as possible in terms of its mass. So that's another interest in eco-design. And we would like, ideally, this product to last as long as possible, so that we don't have to keep substituting that product and worry about end of life of that product. So EOL, we want that to be as period of EOL as long as possible. And because at some stage this product will have to be thrown, we would like to look at how do we think about disassembly upfront so that we could improve the recyclability.